Alright, so for our project we got number 8, which was a digital hourglass. It's basically a small project build of an hourglass with LEDs governed by a tilt switch. Each LED will turn on about 10 minutes each increment. The build takes around 30 minutes to build. It's very, I would say, easy build. So to build this build, we're obviously going to need a very large amount of, I guess you'd say, time in our intervals. For that, we'd have to use our long, which is can count up to about, well, let's say that 4 million, instead of an integer, which would only go up to 32,000. And we need way more. So that would use our long, and for us we'd be using about 600,000 to equal our 10-minute increment, which is basically needed for why we need to use the long instead of the integer. So when we go into our actual code, so at the beginning, obviously, initially, we're going to have to describe our variables, switch pin, previous time, switch state, and previous switch state. These two are going to be compared, obviously, at the beginning to know when the tilt switch and the LEDs need to turn on. Obviously, you have to describe our LED, which is equal to it's the beginning LED. Our intervals, as stated before, we're going to use a long interval of 600,000, which is equal to 10 minutes. Obviously, we tampered with the intervals so that we can show you as a demonstration in our video. So for our setup, obviously we're going to have our inputs from number 2 to 7, which is our LEDs, number 8 being the tilt switch. Obviously the tilt switch is input for an input, not an output. For the loop, we're going to start off, obviously, comparing both the previous state and the current time to show where the tilt switch will be at and when the LEDs need to turn on. So once the switch is actually done, it'll start off with the very first LED from 10 minutes all the way up until the 7th pin, which is the 7th LED. It'll continue on and obviously turn on every single LED. When all the LEDs are turned on, it will sense either some sort of tilt forward, backwards, causing the LEDs to start again from the very first one, LED 2, and begin to light up again all the way up to the 7th LED. And that'll keep going on as a loop. Here in our extensions, it's asking us to build a portable Arduino hourglass. It's made out of basically cardboard, styrofoam, and a battery to make it portable. Be very easy build if we have the stuff to build it with, tools basically. However, we don't have the styrofoam or cardboard to create it. It'd be pretty useful, honestly. Counts up to a whole hour, so you know when an hour is up and you can keep reusing the hour. It goes into asking us for tool switch versus our accelerometers. The tilt switch is very simple compared to the accelerometer. Accelerometer actually gives out a lot of information stated there, and it's really expensive compared to tilt switch, so tilt switch just makes it a lot easier to build with. It senses up and down, which is basically all we need for our build. The second one, or the third one, sorry, asks us to find a way where it could get our attention using the 6 LEDs, either by turning them on in a different pattern way. So instead of going backwards, they go forwards, or the forwards they go backwards. It gives us here a sound or flashing, which are good indicators, but we didn't we didn't go into too much detail on the sound or the flashing. We kind of just went in the pattern way of the LEDs, so going backwards instead of forward. Tasking us to go into the coding basically and mess with it. However, we never really got into messing with it as much, or actually being able to build it.
Alright, going into the hardware. So to start, we have the schematics of the Arduino Chapter 8 project, which right here you can see the 5V is going to the switch, and then it's being grounded with connecting to a 10K resistors, and also there will be a wire going from the tilt switch into pin number 8 to collect the input of the tilt, and then the rest are pins that are connected to the LEDs to write out the output for each loop. After one interval, the LEDs would turn on. Here represents the LED, and then for the LEDs we used the 220 ohms resistors to ground. And onto our build. Our initial build, we start with 6 LEDs and 6 220 ohms resistors, a tilt switch, and a 10K ohms resistors. Our final setup would have look similar to this, with the 5V going into the breadboard's power, and then the ground from the Arduino going to the ground on the breadboard. Here on this right side we have 6 LEDs connected, with the resistors grounding, the 220 ohms resistor grounding the LEDs, and the pin to and the wires connecting to the LEDs to record the output of each interval. And the switch, the tilt switch, which the up direction is this way. So, and then here's the 10K resistor connecting to the tilt switch with the wires in between to read the input of the tilt. And the green wire, small green wire back here, is for powering the tilt switch. We have several videos of our build, of our test. Here's the first video. So after the tilt, all the LEDs should reset, and then starting from LED 2 we will go back up to the last LED, which is in pin number 7. For our test, we shortened our interval time because we didn't have enough time to wait the whole hour to see if all the LEDs would turn on. And this is another test video using different LED color. Here we tilt the switch forward, which would reset the LEDs. And then back to the part of the extensions, using that as for our devices. So we have the LEDs, the 220 ohms resistors, and the 10K resistors. And here it says the tilt switch is great for this problem, because this chapter, because all we need to detect is either the forward or the backward tilt for the tilt switch, and accelerometers would be giving too much information on different directions that we don't need. And then for the switch or the buttons, the reason why we used a 10K resistor instead of a 220 ohms resistor is because for a button, a push button, or similar to that, which is the tilt switch, when you have 5V going through the tilt switch and coming out, if we use a 220 ohms resistor, we would be having around 23 milliamps going from the 5V into the ground. And instead, if we use the 10K, we would be left with a 0.5 milliamps going from flowing from 5 volts to the ground. So while this chapter we had it connect to the laptop, which doesn't change as much in the power consumptions between using either the 10K or the 220 ohms resistors. So the resistors would matter more in a portable version of this chapter, because for the battery there's a limited amount on the of power we can use, and if we use the 220 ohms on the tilt switch, we would be wasting more current or power, which we could use that for extra part, like how it's when we finish lighting up all the LEDs, we could add in a speaker to make an alarm, or we can use it to put in extra LEDs to put up an indicator that all 7 LEDs has turned on. So conclusion, why this project originally said that it would take us 30 minutes to complete. I found it building from the hardware wise, building was not as hard, and it was more simple and clean looking. So most of the works are done in the software part of this chapter, which would take the longer time to mess around with. So going back to this here, so for the extensions where we could add in a speaker or extra indicator LEDs, we would put our code somewhere in this if statement, where when the LEDs reaches pin number 7, we could add in we could have a loop to loop the speaker to make an alarm sound, or we could loop and make the LEDs alternate blinking, so it indicate that all 7 LEDs are turned on. This project was fairly easy to complete. It wasn't as hard as we thought, but we had to do extra research on the reason why we should use different resistors and how the tilt switch was working.